In my previous video, I assembly programmed DHT11 sensor to display temperature and humidity on LEDs connected to digital ports of the 80 mega microcontroller. In this video, the assembly code is modified to display temperature and humidity on MAX7219 7-segment display. The system is modified where the temperature and humidity values from the DHT11 are displayed on the MAX7219 module, which is interfaced with the microcontroller using SPI connection. The sensor is connected to pin PD7 of port D. And now for a quick demonstration. The reliability of measurements will be improved when we utilize the checksum feature of the sensor, which was explained in my previous video. This feature is not used in this project so as not to overcomplicate the assembly code. A flowchart of the complete algorithm is shown here. We begin by initializing the MAX7219 display, and then we send to the display the letters T, C, and H. We apply a delay of 2 seconds, and then we send the start signal to the sensor, and then wait for the response signal. Once we get the response signal, we get the first byte, which is the humidity, and then we get the second byte, which we will not use, and then we get the temperature byte, and then we convert the temperature byte to decimal value and then display it on the MAX7219, and then convert the humidity byte to decimal and then display it on the MAX7219, and then go to point A, which is delay, and repeat the process. A flowchart to convert byte to decimal is shown here. We have the byte saved in a register, and we initialize 2 counters with 0, and then we check the register value. Is it less than 100? If not, then we increment the first counter, and then we subtract from the register the value 100, and then we go back and check the register value against 100. If it is less than 100, then we go to the next level and we check the register value. Is it less than 10? If not, then we increment the second counter, and then we subtract 10 from the register, and we continue with this until R28 or the register is less than 10. So after this step, the decimal value would be a 3-digit value where C1 will represent the most significant digit, C2 the mid digit, and R28 the least significant digit. A quick look at the modified assembly code. First, we initialize the MAX7219, and then we send some letters to the display, and then we call this function DHT11 sensor in order to get the temperature and humidity values and display it on the MAX7219. Inside subroutine DHT11 sensor, we send the start signal and then wait for the response from the sensor, and then we get the first byte, which is the humidity, and save it in register R25, and then we get the second byte, which we won't be using, and then we get the third byte, which is the temperature value. The next step is to convert the temperature and humidity bytes to decimal values and display them on the MAX7219. So we call this subroutine in order to convert the temperature byte into decimal and display it on the MAX7219, and then we call the function again, but this time to convert the humidity value and display it on the display. Inside subroutine binary to decimal, we initialize the 2 counters to have value 0, and then we check the register value, the byte value stored in R28, is it less than 100? If not, we increment the first counter, we subtract from R28 100, and then we loop back and check until the value of R28 is less than 100. Then we jump here and we check the value of R28 against 10. Is it less than 10? If not, we increment the second counter, we subtract from R28 10, and then we jump and check the value of R28 until it is less than 10. In this case, we have the first counter will have the most significant digit, the second counter will have the mid digit, and R28 will have the least significant digit. In our case, we only need the mid digit to represent the most significant digit and the least significant digit stored in R28. Next, we display the most significant digit on the MAX7219 and then display the least significant digit, and then go back to the main subroutine. Inside the main subroutine, and after we display the temperature and the humidity values, we jump to label again and wait for 2 seconds and then repeat the whole process. In a future video, I will assembly program ultrasonic sensor HC-SR04 to compute and display distance between object and sensor. Thank you for watching.